Thank you. All right. Okay, so yeah, welcome to the session, DB2 for ZOS, what you need to know about big data, analytics, and Spark. Here is the agenda for the session. I'll talk about Z, big data analytics in a nutshell. Whoops, it advanced by itself there. Just a moment, it does that sometimes. Then I'll talk about real-time analytics and right-time analytics. Talk about some new data sources for analytics in an IBM Z context. Some new applications of IBM Z analytics technology. And then I'll wrap up with a description of some of the things that DB2 for ZOS brings to the table in an analytics context. So, okay, Z big data analytics in a nutshell. First of all, what is big data analytics? What do we mean by that? I would say that big data analytics is all about what you're doing with data, right? Not so much about the type of data being analyzed, the volume, the structure, et cetera. It's what you're doing with the data. And through big data analytics, you're trying to make data more than just a byproduct of your organization's operations, right? You want to make it an asset, the data itself. You want to make it an asset that can be leveraged, right? To better understand things that have happened, right? What's happened in the past, to more confidently and quickly predict what will happen, to determine what should happen, what's the best course of action, and to find answers to questions that you might not have even considered asking. And all of that so as to reduce costs, to grow revenue, to enhance the experience that your customers have when they deal with your organization, to gain a competitive edge. Basically, right, and bottom line is through big data analytics, right, an organization would aim, right, to use data to get better at whatever it is the organization does. If it's an insurance company, be a better insurance company. If it's a bank, be a better bank. If it's a manufacturer, be a better and more effective manufacturer. Now, okay, why do analytics on Z? A lot of people think of Z as, well, that's my operational workhorse platform. It doesn't really seem to me to be a platform that's well suited for analytics. Actually, it can be very, very well suited for analytics for several reasons. For one thing, we have the technology that enables analytics to actually be infused into Z-based, ZOS-based operational applications, even high-volume transactional applications, to enhance the capabilities of those applications. I'll talk more about that in a little bit. Also, it's often true that the Z platform is where many organizations keep their most valuable data. And when you analyze that data on platform, it can become even more valuable. There are also a number of technologies that include Linux on Z, including open source on Z, including open source in ZOS, zip engines, and the DB2 Analytics Accelerator. These technologies over the past several years have really fundamentally altered the economics of doing analytics on Z. If you've thought, or if people in your organization have thought, well, it's just not cost effective to do analytics on Z, that should be re-examined. A lot's changed in terms of the technology to address that. Also, right, why are often a company's, does a company often have its most valuable data, its most mission critical applications on Z? Because of the platform's reliability, scalability, availability, et cetera. Well, analytics applications are increasingly becoming mission critical, are becoming what a lot of organizations would refer to as tier one applications. And so, okay, as analytics applications themselves become more mission critical, that makes Z a more attractive platform for those applications because of its qualities of service and security, et cetera. And the fact that Z is such a highly scalable platform, because it does have very advanced hybrid transactional analytical capabilities, HTAP, as they say, where a single Z system can perform very effectively simultaneously, handle both high volume transactional applications and analytical applications. Because of that hybrid capability and the platform's scalability, Z can be a very good platform for analytics consolidation, even drawing in data from other platforms to analyze. Moving on now to these concepts of real-time and right-time analytics. So first of all, real-time analytics has, in my mind, a pretty simple definition. I would say that real-time analytics is simply insight that is delivered fast enough to make a difference. And that covers a broad area. For example, you might have a user using a query tool. It could be one of ours, like Cognos or QMF. It could be a tool from another vendor, like Business Objects, for example, and is using a query tool and issues a query, right, against some data. If the response to that query comes back fast enough so that the question, right, that prompted the issuance of that query in the first place, if that question is still in the user's mind, right, then that can prompt the next question, right, which then prompts the next query, right, to drill further into this data, to look at it from a different angle, et cetera. And some people will call that speed of thought analytics. That is an example of fast enough to make a difference. Another example would be, well, suppose that an analytics action is driven within an operational transaction, right? And that analytics action, right, completes fast enough so that the transaction, right, this transactional application, its very stringent response time and throughput requirements are maintained even as these analytic actions are driven within transactions themselves. That's also fast enough to make a difference. Now, in the larger realm of real-time analytics, right, insight fast enough to make a difference, there are subcategories. One is in transaction analytics. I'll talk about that more in just a moment. And then within that category, there's what we call in-transaction scoring. Now, in-transaction analytics, right, is all about taking an analytical action, right, within a transactional event. Why? Broadly speaking, two reasons. To detect what would be an undesirable occurrence in time to keep it from happening, right? It can be valuable to react to a bad thing happening sooner after it happened than later. But if you can spot it before it's even happened and prevent it, right, that's even more valuable. Also, can be used to recognize an opportunity in time to act on it. Certain opportunities are very, very fleeting in nature and are gone very quickly. So you have to recognize them very quickly if you're going to act on them. So when we're talking about in-transaction analytics, the analytics is used to uncover, right, the threat or the opportunity. It shines a light on that, okay? But time is very definitely of the essence because you're looking to tag, to identify something as a threat or an opportunity, but that something you're looking to tag is not going to be there very long. Very shortly, right? What was a threat, okay, a bad thing that could happen, happens. Now it's happened, right? Now you've got to react to a bad thing having happened. The opportunity very quickly is gone, right? If it takes too long to recognize it, it's too late to act on it. It's gone. Now, sometimes the time available to you, right, to get that insight, to flag something and then act on it is in an IT sense, fairly generous. Maybe the transactional event is someone shopping at one of your company's stores or on your company's website. Maybe it's someone who's on the phone with one of your company's customer care representatives. In that case, when it's that kind of transactional event, right, you probably have some number of seconds to use analytics to flag, right, a threat, an opportunity, and act on it. On the other hand, there are other kinds of transactions that could be paying an insurance claim that's been submitted. It could be acting on a credit card purchase, something like that, where the window in which, right, you can act, you can take an analytical action and act on the insight, right? The window in which you can do that might be a tiny, tiny fraction of a second. And that situation, right, where the window in which you can act, get the insight and act on it is exceedingly small, that's where in-transaction scoring comes in. And I'll talk more about that a little later in the presentation. That's real-time analytics, right? And in-transaction analytics and in-transaction scoring are subcategories. Then there's right-time analytics. And so right-time analytics has to do, right, with the opportune time for analyzing data relative to the creation of that data. And in some cases, an opportune time to analyze data is literally years after it's been created. So maybe somebody is analyzing order history, for example, going back, or sales data, going back years, right? And analyzing this large amount of data going back years could yield some very, very valuable insight, right? That could be helpful to the organization. So there's nothing wrong, and it can be entirely appropriate, right, to analyze data long, long after it's been created. But there are other situations in which the value of analyzing data increases as the time between the creation of the data and the analysis of that data decreases, right? And so, for example, paying out insurance claims, right? A problem that insurance companies all deal with, right, is overpayment of claims. So if you can detect an overpayment situation, say an hour after it occurred, instead of a day or a week later, that's good. But what if you could detect, right, what would likely be an overpayment situation before the overpayment itself has actually happened, before the money's gone out the door? That would be taking analysis of the data, the time between the data creation and analysis of the data all the way down to zero, because you're analyzing data within the transaction that creates the data. And sometimes that can lead, right, not to just detection of a negative, what would be a negative occurrence, what could be an opportunity to act on it, right? But prevention of the negative occurrence, right? And actually acting on the opportunity. And so when that value of analytics, right, is really, really big, when you can analyze data at the point of creation, again, that gets into things like in-transaction scoring. More about that in a little bit. Okay, so a little bit about new data sources for Z analytics. So I've been working with DB2 for ZOS for a long, long time as right, an IBM technical support person. I've been on the other side of the desk working in the IT organization of a DB2 for ZOS using company. I've been an independent consultant, so I've seen it from a lot of different angles. And I've been working with analytics type applications involving DB2 for ZOS, going back a good 20 years or more. And for a long time, the conventional wisdom was, well, okay, if you're going to do analytics and you're going to use, right, a ZOS platform for that, okay, well, the data you're analyzing, it's going to have to be in DB2 for ZOS. And not only that, a lot of people would say it's going to have to be in a database that's purpose-built, right, for analytics. It's got a database design that has analytics, right, at the core. And that thinking really no longer applies for several reasons. First of all, the concept of in DB2 for ZOS is bigger than it used to be. I'll talk about that. Additionally, high performance analytics, right, can be done in ZOS, right, in a ZOS system without the database that's being analyzed having what you might call an analytics-oriented design. I'll explain that in just a bit. And the data that you analyze on Z, in ZOS, doesn't even have to be in a traditionally structured form. I'll elaborate on all these things. So first of all, this expansion of the in DB2 concept, when we say, what does it mean for data to be in DB2? It can mean more now than it used to, because of the DB2 Analytics Accelerator, which has been around now for almost 6 years. And what the accelerator does, right? And it's unique in this sense, right? When it first showed up, there were plenty of people who said, oh, right, that's just another one of those analytics appliances. No, it's not, because it uniquely extends a DB2 over z/OS system. You start with a DB2 over z/OS system. When you add an accelerator, you still have that same DB2 over z/OS system, but now with extended capabilities when it comes to handling in a very highly performant way complex and or data-intensive queries. Now, in a physical sense, an analytics accelerator does, alter the picture in that, right, you've got a DB2 over z/OS system, you add an accelerator, and there it is. It's a physical box sitting, presumably right near the IBM Z server where you got DB2 over z/OS. It's got a dedicated, high-speed link to that DB2 over z/OS system, but logically, it's invisible. So before there's an analytics accelerator, applications and users, could be query tools, would see a DB2 over z/OS system. You add an accelerator and they see the same DB2 over z/OS system. So logically, it's invisible, right? Queries still go to the front end DB2. It's just that they can be passed to the accelerator for execution. So there are some implications that go along with having a DB2 system that's been extended by an accelerator. One of those is that you can take data that's in operational DB2 tables, right? Analyze that data using ad hoc queries and get excellent performance, right? Queries that might have taken an hour or more can complete in seconds without having to redesign the database, right? You don't have to take this data from these operational tables and put them into, for example, a star schema where you've got, a fact table and dimension tables. You do not have to do that. The DB2 tables that you want to analyze are simply accelerated. A DBA through the GUI, administrative interface for the accelerator, just selects a table for acceleration, and you've got a copy of it over in the accelerator. The accelerator technology is what then enables this very, very rapid response for complex and or data-intensive queries without having to change the design of the table, right? And another plus, especially from a database administration standpoint, is when data analytics has been done historically in a DB2 over z/OS system, a lot of times the tables have defined on them quite a few indexes to try to speed up some of these queries. That's not needed with the accelerator because the accelerator technology doesn't even use indexes, right? It essentially has one data access path, which is table scan, but it does that exceedingly quickly. Alrighty. More implications of this extended DB2 system, a DB2 system extended by an accelerator. Data can be physically present only in the accelerator, in which case it's only logically present on the front-end DB2 over z/OS system. The front-end system knows about it. There's catalog data about it, but the data doesn't have to exist physically on the front end. One example of that is what's called the high-performance storage saver. It's a feature of the accelerator, and the way that works is, suppose you have a DB2 table, and it's range partitioned, right, on a time series basis. And of course, if you're not real familiar with DB2 over z/OS, this concept of partitioning a table is strictly a physical database design thing. It's something that database administrators do. Database administrators know about it. It's invisible to a program. A partition table looks to a program or a query tool exactly as a non-partition table does. So it's a physical design mechanism. So you can have a range partition table, say partition on, say, like a date. And you could have, for example, maybe 1 week per partition, okay? Well, in that situation, it's not unusual for the only partition to be getting any data change activity to be this week's partition, if you're partitioning by week. It's the current partition. Because with some of these tables, you insert data into the table, and that's it. You don't change it after that. So this week's partition, if you're partitioning by week, is the only one that's getting any data change activity. All the others are effectively read-only. Well, when that's the case, through the high performance storage saver, you've got the current partition, this week's, physically in the front-end DB2 system and in the accelerator, and then all the other partitions, last week, the week before that, et cetera, et cetera, et cetera, or month or whatever you're doing, all of them. It could be hundreds of them, it could be thousands of them. All the other partitions are physically only in the accelerator, thus the storage saver, because the accelerator has its own storage. All right, another example of data being physically present only on the accelerator would be what we, in the form of what we call accelerator-only tables, and a couple of use cases there. One involves data transformation. So a lot of you've probably heard of the term ETL, extract, transform, load. And that's very commonly done in an analytics environment. Something very similar to that is ELT, extract, load, transform, and that can often refer to SQL-based data transformation. And what do we mean by that? It can be in this form. Say you've got data in table A, and you're going to put it in table B, but you're going to do some transformation of the data in doing that. You could do that with an insert, with what we would call a subselect, right? You would say insert into table B, parentheses, select from table A. Well, that select from A could be a pretty involved select statement. It could do a lot in the way of data aggregation. It can transform data, change values using what we call case expressions to make certain values more user-friendly, et cetera. There can be a lot of transformation driven by that query that takes data from A to B. Well, that B table, right, could be an accelerator-only table. And when that's true, then all the cost of that SQL-based transformation is borne on the accelerator instead of on the front end. Yet another example of an accelerator-only table would be, right, a table that receives data by way of the accelerator loader. So this is an additional product. It's a utility, right, that you can acquire if you have an accelerator. And it has multiple uses, but one of the uses of the accelerator loader is to take data from non-relational sources. It could be from VSAM files. It could be from IMS tables. It could be from an database. It could even be relational, but outside of ZOS. You could pull data in from Oracle or SQL Server databases, for example. If it's non-relational data, then part of what the loader does is it facilitates, it helps out with the mapping of that non-relational data to a relational structure, a row and column structure. And once that's happened, then the data can be loaded by the loader into the accelerator in one of two ways. If you want, you can simultaneously load that data into a front-end DB2 table and a table in the accelerator. Why would you do both? That's when you might want to do that so-called HTAP, the hybrid transaction analytical processing, using that data. Because some people find, right, depending on the type of data we're talking about, that even when it's ad hoc query, that they have quite a large volume of what you might consider transactional queries, where maybe a user wants to see, okay, I want to see data for order number, bump, 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 right? I want to see, data, for this supplier or this account, whatever, okay, this case, and so those real quick in and out queries that are maybe done even at high volume are done very, very effectively, right, by front-end DB2 for ZOS, and then the more, complex data-intensive queries can be done on the back end. Or if you want, you can take that data from whatever, the VSAM files, IMS database, whatever, use the loader to put it into an accelerator-only table, in which case, right, it would be only on the accelerator and only logically on the front end. So various use cases for that. There's a new deployment option, relatively new. This came out in the fourth quarter of 2016, the accelerator on cloud, right? So we've got, I think the current version of the on-premise accelerators version 6, right? We've had roughly a new version every year. This is the first version of the DB2 Analytics Accelerator on cloud. So it's a new deployment option. It's in IBM's soft layer, cloud infrastructure. And in an operational sense, very, very similar to an on-premise accelerator in that it's an extension of a DB2 over ZOS system. Logically, it sits behind the DB2 over ZOS front-end system. It's just that instead of sitting there on the raised floor, it's in, the IBM cloud infrastructure. Just like the on-premise one, it's logically transparent, right? Applications, tools don't see it. Queries go through the front-end DB2 over ZOS system. Just like an on-premise accelerator, the data security controls are inherited, if you will, managed through the front-end DB2 over ZOS. So if your ID or the ID of some application, if it does not have the select privilege on table XYZ, and if that table has been accelerated, that ID can't access that data, right? If you can't access it on the front end DB2, you can't access it in the accelerator. Same thing with the accelerator on cloud. And just like the on-premise accelerator, really dramatic speed up, right, of data intensive and or complex queries. But given that it's a cloud deployment, there are some differences that can be advantageous in some situations, including flexibility, which a lot of people like with cloud things, right? It can be, scaled up, scaled down very quickly. It can be deployed very quickly. Some people have analytical requirements that themselves are fairly seasonal in nature, right? And they're transient. They exist for a while and then maybe not. And so when a need comes up, this can be deployed very, very quickly, like within hours. And it is very secure. Some people get a little nervous that, I don't know if I want to put this data in any kind of cloud type, environment. I'm a little worried about security. This is one of these so-called bare metal deployments, right? Your data in an accelerator on cloud is on a machine that's only yours. It's not a multi-tenant environment, and it's encrypted everywhere. It's encrypted at rest. It's encrypted in between your front-end system and the back-end accelerator, so a very high secure option as well. So that's an option for deployment. We still have and fully support the on-prem. We just have another deployment option, which is in the cloud. Now, what about unstructured data? Now, some people say, okay, now, whoa, all right. Okay, ZOS analytics, I get that, but no, you don't analyze unstructured data in ZOS, do you? Well, you can, and it actually could be very useful. Why? Because integrating the kind of structured, highly structured data that we tend to find in ZOS, integrating that with non-traditionally structured data can actually yield breakthrough insights. So a couple of years ago, Information Week magazine, they had their annual analytics and BI, business intelligence survey, and it was interesting. That survey found that the number one factor, right, driving interest in data analysis was, quote, finding correlations across multiple disparate sources, which could include click streams, geospatial data, transactional data, right, which tends to live very often in ZOS. So analyzing that transactional data just by itself, that can yield a lot of value, but if you analyze that transactional data together with, non-traditionally structured data, then you could find insights that you had no idea were there. Another reason for analyzing, non-traditionally structured data in ZOS is there actually is data that lives, that's born in ZOS, that we don't think of as being traditionally structured for analysis. Things like SMF trace data, things like syslog data. This is data that a ZOS system is generating all the time to basically tell you how it's doing, what's going on. And so, right, there's all this talk, and right, well, there should be, not just talk, lots of action, a lot going on around IoT, the Internet of Things, right? Things talking to other things, right? Well, in a sense, right, a ZOS system is talking all the time, and what it's saying is in SMF data. It's in syslog data. You have an opportunity to analyze that. Listen to what ZOS is saying in real time. How could you analyze unstructured data in ZOS? You might think, well, if I'm going to analyze unstructured data, I mean, I've got to send it outside ZOS, right? Even if it was born in ZOS. No, because one of your options in ZOS is you can deploy, you can run Apache Spark in ZOS. So Apache Spark is open source software. Open source software. And you may have noticed, right, especially in the last couple of years, there is a very large and growing commitment on the part of IBM to support open source software, including on Z. And some people might say, oh, right, I get it. Yeah, you can run open source, various things under Linux on Z, for example. Yes, but also in ZOS. It can run natively in ZOS, right, Apache Spark, and use zip MIPS, right, which are less expensive than general purpose engine MIPS, because even though Spark is written in a language called Scala, right, when you compile a Scala program, what you get at the other end of that compile process is Java bytecode, right? And Java runs very, very well in a ZOS environment and uses zip MIPS. Native Apache Spark, right? Native open source Apache Spark can natively access data in a Hadoop data store, can also natively access any data server that has a JDBC interface. Of course, that includes DB2 for ZOS. That also includes IMS. IMS has a JDBC interface. Now, we provide something called the ZOS platform for Apache Spark. Yes, that's a piece of licensed software, but it's like really, really inexpensive. The license is practically free. It's just service and support, basically. Anyway, what that does is it provides on top of open source Apache Spark, among other things, these connectors that allow Spark to ingest data from sources that don't have a JDBC interface. Things like vSAM files or an database, PDSEs, right, partition data sets, physical sequential files, syslog data, SMF data. So all this stuff, right? So through the ZOS platform for Apache Spark, and this is part of what's driving the interest in this, is the ability to integrate in ZOS data from a lot of different sources, right? Structured, highly structured, less structured, relational type, non-relational type. Bring it all together. It also provides, from a data scientist perspective, abstraction of a ZOS system. So plenty of data scientists would say, I don't do mainframe. I don't really know that. Well, do you know Spark? Oh, sure, I know Spark. Okay, fine, work with this. Don't worry that it's in ZOS. It's just Spark, okay? A little bit more about Spark. So I mentioned it can be very handy and useful for data integration. It can bring in data, right, and combine data from so many different sources. It also delivers high-performance analytics. How does it do that? It takes this data from one or more sources, and with that data, it builds these in-memory data structures, somewhat analogous, to certain products, Cognos, for example, that can build what's called a cube, right? Somewhat similar to that conceptually. Builds this in-memory data structure, and subsequent access to that in-memory data structure is very, very fast. Also provides support for some really important languages from an analytics point of view. So R and Python are examples of a couple of languages that are very popular with data scientists, very popular, commonly used for statistical analysis of data. And Spark has interfaces for those languages. Spark has machine learning capabilities. I'll be talking more about machine learning in a little bit. Spark has a streaming capability. It can break data that's streaming into Spark, right, into these little mini batches and analyze those and give you insight in real time. Also has this so-called GraphX engine to do graph processing, which can be useful for analysis of data of a type that you think of, that you conceptualize maybe in a spatial sense. And so the example given here is, what if there's a social media site and all these people have their profiles, and this person's profile is linked to that one, who's linked to that one, who's linked to that one. What's the shortest distance, between a couple of people in this social media world as far as linking profiles? GraphX can be very handy for that kind of analysis. That's part of Apache Spark. So it really is, Apache Spark has a very rich feature set for data analytics. It's a framework for data analytics. Okay, a little bit more about new applications. Basically, new ways people are thinking about doing analytics on Z, especially in ZOS. So historically, what people have done when they do analytics in ZOS, and people have been doing that a long time, right? I mean, I was working for IBM when we announced DB2. And yes, we invented relational technology. And I remember one of the very early so-called red books, and this was back when red books actually had red covers. And so this was version 1, release 1 of DB2, and it actually had like a warning in there. This database management system is designed for data analytics. Basically said, don't use it for transactional stuff. And of course, people ignored that. They used it for transactions anyway. Performance was crummy, but we fixed that over the years. Anyway, so that's DB2's roots. But people would use it to see what happened, right? Let me analyze this historical data. Okay, that's still useful. That's still definitely useful, but there are new possibilities for analytics and ZOS that haven't necessarily occurred to people, and these new types of analysis involving ZOS and data in ZOS, it could just be done on premise. It could be a combination of on-premise and cloud kind of technologies. Just one example, right? This whole data integration thing could be to get a more complete view of customers. And so you might have a retailer, right? And that retailer's got transactional data maybe that lives for example, in DB2 for ZOS, or it could be in an IMS or VSAM files. Anyway, transactional data, and that is data that's exclusively theirs. Nobody else has that. There might also be data that's exclusively theirs, but it's differently structured. So it could be customer call transcripts. Maybe they keep transcripts, whether it's in text or audio or both, right, of customer calls, and they keep that. That's not traditionally structured. Maybe that's kept in a Hadoop data store on site. That's still exclusively theirs. They might add to this data that's exclusively theirs, data from outside the organization about their customers that they could glean from social media sites. They could combine it all, and one option would be to do that through Spark in ZOS, which can pull in data, right, from Hadoop data stores, anything with a JDBC interface. We've got the interfaces to things like VSAM data if you want to do it for that. Bring it all in, crunch it, analyze it, and then be able to come up, right, having this much more complete view of a customer, to have much more highly personalized offers. And so if you've got a customer named Jeanette Moore, right, an offer that's really tailored to Jeanette and not just some generic, female between age 25 and 30, blah, 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 much more specifically targeted, which tends to generate not only new sales, but loyalty. People often appreciate an offer that they can tell is targeted to them. What about turning data into a new revenue stream? What if you could actually make money off the data you have, not by selling the data? You retain ownership and control of the data, but you're basically, what if you sold data about the data, okay? So just, an example. What if there's a bank that has maybe in ZOS lots of data that's related to home improvement loans, and maybe while maintaining control of that source data and protecting, privacy of who is this data pertain to, right? Protecting the stuff that's got to be protected, but otherwise selling information about that data. That could be potentially a for-fee service that maybe contractors, that maybe suppliers would use to better able them to serve the market, to make them more responsive to the market. That information, right, could be queryable from mobile devices, right, using REST APIs, because through ZOS Connect, when you may have heard of that some this week and before this week, ZOS Connect allows you to REST enable all kinds of ZOS-based programmatic assets, which could be SQL statements, right, could be queries, things like that about this data. Not only could you allow people, right, to query this data, but maybe your own data analysts could crunch the data, come up with interesting insights, and then get pushed to subscribers of this service. Okay, hey, here is information about, trends in kitchen renovations in these various areas, et cetera, et cetera. And so the point is, people are looking at the data they've got and starting to think, are there parties outside of our organization that would actually get enough value out of this data if we present it the right way that they'd pay for it? Again, in a way that we aren't giving up our control or ownership of the data, right? We're selling data about the data, but in a way that is valuable enough that it becomes a revenue stream. That's happening more and more. And ZOS plays there. The new frontier is machine learning. And so kind of in a big picture sense, machine learning is at its core about computer systems, right, that learn without being explicitly programmed. So, you do some degree of training, if you will, and then, the machine learning technology takes it from there and gains more knowledge itself without you having to spoon feed everything to it. So it takes data, ingests it, performs analysis, and provides insight. Okay, that's nice in terms of big concepts. What does it mean to a business? So the business sense of it is this. Basically, when you, in a business analytics context, when you hear about machine learning, think predictive models. And predictive models are all about, right, discovery of patterns in data, right? Having discovered these patterns in past data, then when new data comes in, you can use these models, right, to say, okay, when the following is true, this is likely to happen, okay? And that can be done, used by analysts who are doing, planning for the organization. It can also be used within transactions. So there's growing interest in these predictive models, right? Because they can allow you to figure out intelligently, in a data-driven way, right, what's going to happen. And that could be useful to know. If I'm pretty sure, right, that if I process this payment in the normal way, it's going to end up being a fraudulent, transaction. Okay, stop. Don't process it the normal way. If I can see that, oh my gosh, right now, with this person, on the line or on our website or in our store, this particular individual, there's a high probability that he or she, if we offer this and or that, they'll buy it. Do it now. That kind of thing. There's growing interest in that, but it has traditionally been a pretty labor-intensive process. There's no magic. It's like, oh, snap your finger, there's a crystal ball. No. There's all this stuff that's got to happen involving data ingestion and data preparation, training a model, right? Deploying the model. How do you do that? And then using it, right, to actually make predictions that programs can act on, et cetera. And a lot of this involves a lot of time on the part of data scientists. And what we've been seeing, and a lot of organizations have been telling us, is the demand that organizations have for this predictive capability is outstripping what their data scientists can do. And so, oh, yes.
Predictive models is that we have a lot of manual operational processes.
Mm-hmm.
So I don't know if people really think about this, but you have to make the data more predictive too. In other words, automate the manual processes so you can be more predictive. Because if it's not predictive, then it's garbage out.
Mm-hmm.
Makes sense?
Yeah. So the point is
Stop processes because we want to check something and all this, that auto validation and all this other stuff.
Yeah. A point is that this predictive capability can have a lot to do with driving automated processes in all kinds of ways. It can even be integrated. For example, there are ways to take a predictive model and in essence call out to it from a so-called rules engine, right? IBM and other vendors have software that's called rules engines, that are called rules engines. You can author business rules, put them in a rules repository, and then instead of building these rules, hard coding them into programs, right? And maybe the same rules in a bunch of programs, you want to change it, it's a rig headache, it's inconsistently done. You put it in the rules engine, and the programs just access the rules there, make it a lot easier to change things. Well, these rules engines, right, can call out to a predictive model, get a score back, which might determine, do I go this way or that way? A fork in the road or something like that. So it can be a big part of automation, lots and lots of applications of it, but very labor intensive, right? And so along comes machine learning. So with IBM machine learning, what we're really trying to do is make this technology be what you might think of as a force multiplier for data scientists. Conceptually, it's kind of similar. We're looking to do for data scientists what DevOps has done for application developers. Enable application developers to be more productive, be more agile in what they do, right? Same kind of thing for data scientists. So with machine learning, a big part of what we're trying to do is drive a lot more automation and intelligence into especially a lot of the real time intensive stuff that data scientists have to do so they can use, right, their knowledge in sort of more highly productive, more valuable ways, right? So things like ingesting data and preparing data that can take a huge amount of a data scientist's time, much, much faster with the IBM machine learning, the training of models, deploying models. It provides an infrastructure to deploy a model so it can be invoked by way of a REST call, for example, from, for example, a Kix transaction, and get an answer back like in a millisecond or something, okay? And that could maybe be a score. And if the score is like this or above, it means, whoa, okay, danger, warning, warning, probably a fraud, stop, take an off ramp, right? Or if the score is this, means opportunity for cross-sell, do it now, okay, that kind of thing. So deploying it, not only that though, but monitoring the model. So what if over time, so it's making these predictions, but it's also tracking the accuracy. Did what we thought would happen, happen? And what if over time you start to see a divergence? What if it's losing some accuracy? The machine learning is monitoring that on a continuous basis and can alert, hey, we've got a divergence here and it's growing. This model is going to need to be adjusted, and then help do that more quickly, right? And so maybe you take some new data into account, you update the model, so now it's back to being more accurate in its predictions, et cetera, and managing the models, right? So the more models you're using, it's like a lot of other things in application development land, management starts to becoming more and more of an issue, right? And what do we have deployed where, and are there different versions of these things? Do we need to retire some things? Do we need to revert back to a previous version, et cetera, et cetera? So managing all of it, and what's kind of interesting is, right, our very first deployment of IBM machine learning was in z/OS, right? It's also available in our cloud, right, in the so-called Bluemix cloud infrastructure. But our first deployment of it was for z/OS. And that enables you to use machine learning to analyze, access and analyze z/OS-based data in place on the most secure platform in z/OS. Use live transactional data, right, to come up with the most accurate models possible. Scales up for the biggest applications you can run in z/OS. It does allow you, right, to combine this data from structured and unstructured data. It allows the infusion of predictive applications, right, through the ability to invoke a predictive model, right, through a REST call for applications that are in z/OS, right, to infuse them into operational applications, even when, right, they've got very, very stringent response time and throughput needs, so that more opportunities can be converted into revenue, to optimize, right, the use of resources, to automatically identify, right, and manage risk before bad things happen, disrupt the competition and the disruptors. And so lots and lots of companies, rightly, big companies, right, I work for one that's been around for 100 years, are rightly looking over their shoulders. Who's coming up behind me? And it's happened with all these different companies. It happens in IT, right? It's happened in my 30 plus years in IT. Lots of disruptions have come along. And I've been, oh my gosh, am I just going to be taken out by a disruptor? But one thing to keep in mind is if you work for an established company, one thing you've got that the disruptors don't is an enormous amount of data. That's about what you've been doing maybe for decades, maybe for scores of years, and that could be a huge asset. Just use one example from way back. Some of you might remember, and I'm dating myself, Laker Airways. I think that was back like in the 70s. Sir Freddie Laker came up with an innovative, new airline that offered really cheap transatlantic seats, got a lot of business, but eventually went out of business. And he said in an interview, what really took us out was American Airlines yield management system. And so American, and they're not the only airline that can do this, but they were pretty sophisticated. They figured out, right, how to analyze yield on seats on an individual seat basis. So they could always make sure they sold at least some seats on these transatlantic flights at prices that were at or lower than Sir Freddie's, but sell others, depending on when you bought it, blah, 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 that gave them a lot more profit than what Freddie was going. It was their use of information that took out a disruptor. All right, so finally, DB212. What does DB212 bring to the table? Generally available in October of last year. Among other things, took the scalability limits we had before and just blew them out, right? Up to 4,000 terabytes of data, up to 280 trillion with a T rows in one table. Tremendous new flexibility when it comes to dealing with managing partition tables. Talking about range partition tables in particular. You could have different partitions of the same table, have different data set sizes. Could never do that before. One partition in a partition table can hold up to a terabyte of data. Data ingestion, when things are like, Internet of Things type applications, when I've got maybe a huge amount of data, coming into the system, can DB2 for ZOS ingest it? We can drive literally, and we've done it, millions of inserts per second into a DB2 for ZOS table. Another thing that 12 brings to the picture that's very helpful from an analytics perspective is this sort of closed loop when it comes to statistics maintenance. And the first item, that first bullet, so the DB212 optimizer, a whole lot of attention was paid to greatly reducing the CPU cost of fairly complex queries, which you might think, I guess that's when a user's doing this and point and click with this GUI tool. There are applications that you might think of as operational in nature. Maybe you're running them, that you buy from various vendors, right, that involve very complex queries in terms of outer joins and complex unions and user-defined functions that might be table functions, et cetera, et cetera. So these really complex queries is a big focus of the DB212 optimizer, and some of those, right, end up costing 1/10 of what they did before in CPU time. This closed loop for statistics management, especially when it's ad hoc, dynamic SQL, the statistics in the catalog are really, really important. They got to be accurate, got to be consistent, got to be complete, right? But that was always on you to do that. Well, 11 helped a little bit in that with DB211, the optimizer could notice, right? So it would optimize a query, and the optimizer, in doing that, would say, all right, I notice we've got some statistics that are inconsistent here, which could happen maybe if some of them have been like user updated, et cetera. Or maybe I'm missing some critical information that would really help me with this kind of query, or it's way out of date or whatever, and would provide that information in a catalog table called sysstat feedback, right? But then either you or some tool had to act on that. Well, with DB212, it closes a loop because the optimizer provides that feedback, and then DB212 takes that feedback, updates data in these profiles, right, which are basically run stats specifications. So when you do run stats for a certain table space, you use that profile, right? It'll update the profile so the next time you run stats for the table, it's going to gather the stuff that the optimizer says is missing or is inconsistent or whatever. It's going to fix what the optimizer said is wrong. And some people say, well, that's great, but it relies on profiles, and profiles can only be used with run stats. And almost all the statistics we generate in my shop are the inline variety. We do a reorg, we do a load, and we do inline stats. And profiles don't help there. With 12, they do. With DB212, profiles are for the first time applicable to inline stats. So with DB212, you definitely want to be using profiles, and that's why, right? They'll be automatically updated and refined. And then the REST interface. So I briefly mentioned the REST interface. I talked about it in terms of ZOS Connect. That's a route into it. But in a strictly DB2 context, DB212, a REST interface was built into 12, natively into 12. It was retrofitted to 11 by way of the fix for APAR PI 66828. And it's built on DDF, so you're leveraging the DB2 distributed data facility infrastructure. And what it allows, it lets you REST enable a single static SQL statement. That could be a query, for example. It could be a call to a stored procedure, which might involve any number of SQL statements being executed, all right? So can REST enable through a REST call, right? A very straightforward, consistent service invocation interface, very popular with a lot of application developers, often when it's a mobile-fronted application, cloud-based, but not only that, right? Plenty of developers are working on applications that have nothing to do with cloud, nothing to do with mobile, want to use REST. Why? They like that level of abstraction. They want what they call data as a service. One of the nice things about this from a developer's point of view is data goes back and forth, right, when you're using this interface in what's called JSON format, JavaScript object notation. That's also very simple. This is a very simple JSON document. You can see what it is. It's not mysterious. George is somebody's name. 29 is George's age. USA is George's country. It's just name-value pairs that are set off by brackets, right? You can easily parse that. So can a program, right? And there are two ways to get to it. A client program, right, could go directly to DB2's native REST interface or could go through ZOS Connect. When you're doing the latter, you're still using DB2's native REST interface. In that case, DB2 becomes a REST provider to ZOS Connect, right? And ZOS Connect then also enables REST, creation of RESTful services using all kinds of ZOS-based programmatic assets, not just SQL statements, which could be store procedure calls, but also KICS transactions, which could involve access to DB2 or maybe vSAM data. IMS transactions, which might involve access to DB2 or maybe to IMSDB data, right? WAS for WebStream App Server for ZOS transactions, batch jobs, et cetera. All can be REST enabled through ZOS Connect. And then finally, the utilities enhancements too, right? You got to actually manage and administer the data. So DB212 helps there. More zip offload, right? It's always nice to get more zip, especially for reorg and load, right? That reduces cost of computing. We got a nifty new load option. Load, replace, share level reference, so you can have programs reading data as you're doing load replace on a table. And at the end, we're just loading into another instance of the table. And at the end, we just switch it over. Resiliency. Partition by growth table space are becoming increasingly popular. One problem is if you did a partition level reorg, you reestablish free space and it won't fit back in there, it fails, right? With DB212, if it needs to add another partition at the end of the table to accommodate overflow when you're doing a partition level reorg, it'll do that, so it won't fail anymore, okay? And with that, I am done. Here's the handy dandy little QR code for your eval, which I hope you'll submit. Your feedback's important to share, important to me. But other than that, I'll just say thanks for coming and enjoy the rest of the conference.
Because we share. Because we share.